Hi, my name is Ann Scanello. I'm one of the tutors with the Seeds of Literacy program. Today, I'm going to run you through a lesson on just solving basic GED practice test questions. The questions that I'm using can be found online at this address. To watch the video, you do not need to go to that address, but my thoughts were after you've worked through the video with me, give it a few days, go to that address and take the exact same test online and see if you're able to complete the problems on your own. Our learning goals today are, first of all, to get familiar with the GED Formula Page that they'll offer you when you start the test. Get familiar with the online calculator. I always encourage calculator use on a timed test like this. Many of my students at Seeds say that they would rather work it out the long way and they want to use the paper and pencil. But even I, as a math teacher, when I went to take the test and it was timed, I found that I was running short on time. So anything we can do to speed that up. And then we're going to work through the 10 practice GED questions. The formula page has several sections. It starts with geometry. You've got a section on area and volume. You've got perimeters. They cover surface areas and volumes. You've got some data formulas. You've got algebra, both linear and quadratic formulas. And then you've got some basic interest formulas and the distance formulas and some things like that. The calculator that they allow you to use online will look something like this. I think I've seen some of these in the Seeds office, not that any of us have been to the Seeds office recently. The most important thing that's changed about a calculator since I was in math class many years ago is that now each of the keys has got two functions. So you've got their main function written in white on the actual calculator key. And then above the key in bright yellow, they've got the second function. For instance, the key that I'm circling with my red pointer is actually a fraction key. You now can input a fraction into the calculator. But the second function of that key is to put a whole number, a mixed number, a whole number with a fraction. In order to get the key to perform the yellow function above, we first press the yellow second button and then press this button. We'll practice a little bit of that. So they have on this website that I have listed on the title page an actual calculator reference sheet. I'm not going to go through this whole thing, but you certainly could to get familiar with it if you have not used a calculator similar to the TI-30XS before. A couple of things I wanted to highlight is when you're inputting numbers and they're negative numbers, many of my students think they should use the subtraction sign. That is incorrect. And sometimes you will get an error message when you do that. So always make sure you use the negative sign, which is just to the left of enter at the bottom of the calculator. I have it circled in green. Percentages, they have got an actual percentage function on the calculator. And I would hope that most students know that you could turn a number like 12% into a decimal by just moving that decimal point 2 places. But I see so many errors turning percentages into decimals. I thought that it'd be a good idea to actually practice using the percent key on the calculator. Because it's written in yellow above that parentheses, you have to press the second button first, then that button. Scientific notation. We don't have any problems using scientific notation today, but there is a scientific notation button on the calculator. And it is right here, circled in green. And they actually go through the keystrokes that you would put in to input a scientific notation problem. The keys that I've circled in red, the top right section of the calculator, is 4 arrows, up, down, left, and right. And those are the arrows that you use to advance the place on the screen. We will have a couple of examples of that. You use that anytime you're using an exponent or you're putting in a fraction, you're going to have these teeny tiny numbers that show up on the calculator, and you'll have a hard time getting it to go back to your next big number or your addition sign or whatever. And so you'll have to actually click the right arrow to make it advance ahead so that you can tell the calculator, I'm finished with my exponent or I'm finished with my fraction. Fractions, this button we already talked about. You press that button as they're showing you, and then you input the 2 in the screen, and then you arrow down to get to the bottom part of the fraction, and you put in the 9, and that's how you would put in 2/9. The mixed numbers, like I said, it's the yellow function or the second function of the fraction key. Same thing, but you're going to have to use these arrow keys in order to move the blinking cursor where you want it to go on the mixed number. The powers and roots, any of your exponents or your roots, you've got a couple of buttons. You've got the x squared button is circled in purple at the bottom. In blue, we've got a caret, or it looks like an up arrow. Any exponent greater than 2, like 3, 4, 5, you would press that up arrow and then put in the number. And then you're going to have to use the advanced key. They'll walk you through all of this. The second function of x squared is the square root. And then the second function of the exponent button is roots beyond square roots, like cube roots or the fourth root, anything like that. The toggle key, this can be a really helpful button. It is circled in purple, bottom right of the screen, right above enter, which is the same thing as equals. Sometimes your calculator, because we can now input fractions into a calculator, they might give you the answer as a fraction, and perhaps you need the answer as a decimal. The toggle key, the one with 2 arrows going to the left and right, will turn your answer back and forth from a fraction to a decimal. And if you've got a decimal and you need a fraction answer, press that button and it will turn your decimal into a fraction. Okay, the 3 things that I find the most helpful for students to review before using a calculator like this are the negative sign. Make sure you use the negative sign to the left of the enter button. I have it circled in red. Make sure you use that key. Do not use the subtraction key. The arrows, anytime you're working on a function and you can't get the blinking cursor to go where you want it, you need to use these arrows that I have circled in blue. And then the toggle key. If you get an answer, it's a fraction, you need a decimal, press that toggle key, it will convert it for you, and it will also go from a decimal back to a fraction. Okay, so now we need to start working some of these problems. This is the first problem. It says a painter rented a wallpaper steamer at 9 a.m. and returned it at 4 p.m. He paid a total of $28.84. What was the rental cost per hour? At this point, I would recommend that you pause the video and solve this problem yourself. When you finish solving it, turn the video back on. Okay, the video's back on now. First thing we have to do is decide how many hours we are renting this wallpaper steamer. And from 9 a.m. to 4 p.m., there are 7 hours. I just counted on my fingers. And we know that we paid a total of $28.84. That was just a simple division problem. 28.84 divided by 7 equals $4.12. That happens to be option C, so you should select option C. Practice number 2. What is the value of 36x minus 8y squared when x equals 3 and y equals negative 6. Go ahead and pause the video and solve this problem. Okay, the video is back on now. This is just a simple substitution problem. I rewrote the problem, as I typically do, 36x minus 8y squared. But they told us that x is going to equal 3 and y is going to equal negative 6. That simply means in the spot where we had x, we're going to put the number 3. And in the spot where we had y, we're going to put the number negative 6. I always use parentheses because that will let your calculator or your own brain know that 3 is a separate number and that 3 needs to be multiplied by 36. The same way 36x means 36 is multiplied by x. And here's what I wanted to show you about the calculator. So there's my calculator on the screen. I hope that you can see it. A lot of students will want to work this problem out long ways. It will go much faster if you use the calculator. And your calculator has so many operations programmed into it, things like PEMDAS. It knows how to do it. And so you can avoid mistakes by inputting the equation exactly as it's written. So I'm going to do that. So it's 36. My calculator has got open parentheses. I'm going to use it. It's a 3, close parentheses. This is subtract 8, open parentheses. I'm going to use my negative sign for negative 6, close parentheses, and I'm going to use my x squared to square that value. Okay, now look at my calculator screen. I inputted it exactly the way I have it written right here. And now the calculator is responsible for knowing, you know, do I do the exponent first? Do I do the subtraction first? When does the multiplication happen? And I press enter because that's my equals button. And it says it's going to be negative 180. And that is correct, negative 180. That is option B. Nice. Okay, practice 3. Annie is planning a business meeting for her company. She has a budget of $1,325 for renting a meeting room at a local hotel and for providing lunch. She expects 26 people to attend the meeting. The cost of renting the meeting room is $270. Which of these inequalities shows how to find the amount X Annie can spend on lunch for each person? You have 4 options that all look very similar, that are all using the numbers from the problem. So this one can be a little tricky. So go ahead and pause the video and solve it for yourself. Okay, the video is back on now. And I want to remind you that you've got the GED Formula Page. And on that, we've got something called the slope-intercept form of the equation of a line. I used to just refer to it in my classroom as the standard equation of a line. Y equals mx plus b. I have several videos, and so do other tutors, explaining how to use that formula. But this is a quick little note page that I put together. The formula y equals mx plus b. In this, your dependent variable is going to go in the position of y. In the position of m, that's where you're going to substitute in or input in your slope. Sometimes it's called unit rate. I've seen it called constant of proportionality, and you'll hear it called coefficient of x. In the blue for the x, that will be where you input your independent variable. And the b is the y-intercept. In a word problem, it's probably going to be the beginning amount of something or the starting point. When you're looking at a table, it's going to be the value of y when x equals 0. At this point, I would highly recommend that you stop and take a screenshot of this note page. This is information that you have to memorize before you go in to take the test. So, and if you can't take a screenshot, just jot this down. Moving on. Okay, so we're back to our problem. So we're planning the business meeting. Our budget is $1,325. 26 people are coming. The meeting room is going to cost $270. Okay, so I wrote down those known pieces of information. And I also wrote down the standard equation of a line, y equals mx plus b. Now all we have to do is substitute the known, the givens in the problem into the equation. So the first thing, the first thing we want to substitute is for m. And if you'll remember from that page that I told you to jot down for notes, that's going to be the slope or the rate for the problem. Well, they've told us that we are going to have 26 people attending, and so that will be the slope for the problem. It's kind of weird the way they worded this one, but the y-intercept is a little easier to place. So now, we know we're going to put 26 where the letter M is. And so now the letter B is our y-intercept. And we said in a word problem that is frequently going to be the starting point or the beginning amount. So when she is paying the bill for this business meeting, before a single person attends or a single person eats lunch at all, how much is she going to have to start off paying? Well, she's going to have to pay for the room. So even before anyone has their lunch, she's going to have to pay $270. That's a one-time charge. You don't pay that for every person that comes. You just pay it once. So we're going to substitute those two values in the spot for the M, or the slope, and the spot for B, which is the y-intercept, or the beginning amount. So now we've got something that looks a little bit closer to our options, but we still have y as our dependent variable. This equation that we've come up with is a way that Annie could calculate the total cost that she's going to have to spend, for a particular price for a lunch for that day. Well, they've told us what our total cost is allowed to be. Our total cost is $1,325. It can be less than that, but it can't be more than that. So we can substitute 1,325 in for y. Now also, in my equation, standard equation of a line, I had an equal sign. On the right side of my equation, this was the cost for the meeting. And on the left side, this is the total. So you could say on the right side is the expenses, and then the left side was the total. So because $1,325 is our budget and we can't go over that, we're going to, instead of using an equal sign, we're going to use an inequality sign. So I have to say to myself, the total that I'm spending, can that be more than the cost? Or can the total amount I spend, should that be less than the total cost? Or the total amount that I spend on the right side, should that be more than the total cost? So you can see I have a greater than or equal to sign here. The small side of the symbol is pointing towards the cost, because the costs need to be smaller than $1,325. The large side of the symbol is our budget, because that has got to be the biggest amount possible. The cost can be smaller than that, but it can't be bigger than that. Now, the way I wrote my equation still looks different than their options. They put total costs on the right, and I put total costs on the left. The most important thing is that you remember that the large side, or the greater than side of the symbol, is facing $1,325. And that would be the case for option B. We have our 26X matches plus our starting point of $270 for the room cost. Those costs are on the smaller end of the symbol, and our budget that we have to stay under is $1,325. So it matches up to option B. Practice question number 4. Dominique earns $285 per week plus an 8% commission rate on all his sales. If Dominique sells $4,213 worth of merchandise in 1 week, how much will his total earnings for the week be? Okay, so when you are selling something and you are paid a commission, it means that you get that percent of all your sales. So what do we know here? We know that Dominique's salary is going to be $285 plus he gets 8% of everything he sold that week. Now, there are also several videos talking about strategies for solving word problems. The word of is a special keyword. Anytime you can restate a math problem using the word of, that is typically going to be multiplication. So in order to find Dominique's salary, we're going to take $285 and we're going to add to that 8% times by his weekly sales. So I wrote it up like this: $285 plus, and hopefully you know that 8% can be turned into a decimal by moving that decimal 2 places, and 0.08 is the same thing as 8%. And then we're going to multiply it by the 4,213. So our calculator, this is a time when I might recommend that if you're not great at turning percents into decimals, that you actually let the calculator do that part for you. I'm going to type it into the calculator. I could type it in exactly the way I had it written, but I'm going to type it in a little bit differently. And this calculator, well, I'll show you that in a second. Okay. Let me clear and keystrokes. Okay. So now I can see what I'm actually typing in. I'm going to type in 285, and I'm going to say plus, and instead of putting in 0.08, I'm going to put in 8, and then I'm going to locate the percent key. It's actually a second function. It's written above the division key on this particular calculator. So because it's the second function written in light blue, I'm going to click the second button first. And now I'm going to click the division button, but it's going to give me percent. And now I'm going to put in my parentheses so it knows it's a separate number, $4,213. And now I'm going to close my parentheses. This is kind of a cool feature of this calculator. It will let me show you the keys that I actually pressed to get this showing on my screen. The second function, and the percent key shows you the parentheses that I hit. Okay, so now we've got all of that. Now I'm going to press enter, and my answer is $622.04, and that is an option B. Number 5. This one is a really long question. They actually continue this question for question 6 and question 7. Let's go ahead and read through it first. A scientist is studying red maple tree growth in a state park. She measured the trunk diameters of a sample of trees in the same month every other year. The table shows the data for two of the trees. So we've got data for tree 1 and we've got data for tree 2. It's arranged by year, and remember, she didn't do it every year, every other year. And then she's got the size of the diameter, and that's all in inches. And it says, this is the final year in which she will collect data. When her data collection is complete, she will predict future red maple tree growth. Okay. The scientist plots the data for tree 2 on a coordinate grid. She begins by plotting data for year 3 and year 11. What are the locations of the 2 points on the coordinated grid? And then it tells you click on the grid to plot the points, and then to remove, you can place the arrow over the point and click the left mouse button. I don't have that luxury the way my program is set up. But the most important thing is they've given us a lot of data, and they only want us to use a very small portion of it. So let's make sure that we are focusing in on just the data for tree 2 and only on years 3 and year 11. Okay, so here's the coordinate grid that they've got. And the coordinate grid, anytime you've got a coordinate grid, if you will look carefully, the horizontal line along the bottom, on the far right of it, there should be an arrowhead, and there will virtually always be the letter X. That is your X-axis, and that's where you plot your X values. And then the vertical axis is going to be your Y-axis, and so I circled that in purple. Now, anytime you've got a table, mathematicians like to do things in an orderly fashion. And so your first column of values will always be your X values, and your second column of values will always be your Y values. If you've got a horizontal table, the top values are always X, the bottom values are always Y. Okay, but so now that we know that, let me see, we are looking at year 3, so we go along the X-axis to find year 3, it's right here. And now we have to go all the way up to 12.0, and we have to be very careful to find the intersection of 3 years and 12 inches. And then we click, and there's our point. And now we have to find 11 years. So go over to 11 years, and we go up to 14.4. And I was reading the explanation on this one. Most of the explanations are not helpful at all, but this one made a point of saying, you have to understand that you have to plot this value not at exactly 14 or exactly 15, but you've got to estimate it, and it needs to be slightly less than half the distance between 14 and 15. So I'm putting it right about there. Oops, I ooched it. And I'm putting the point right there. And that's the correct answer. Okay, we're continuing our problem, but this time the scientist creates an equation that models her data for each tree so that she can predict the diameter in the future. It's your job to complete a linear equation that fits the data for tree 1, where X is the year and Y is the trunk diameter in inches. Click on the variables and number you want to select and drag them into the boxes. Okay, this is the only, all of the problems today that we're going over are worth 1 point. This one is worth 2 points, and I have a feeling it's because we've got 3 answers that we've got to input, and so they're going to count that somehow as 2 points. Okay, but again, we are given a lot of data, but we are only interested in the information for tree 1. So we need to focus in on just tree 1's chart. Okay, so they said that we're going to write an equation for this linear relationship. Remember our GED formula page, right there, the slope-intercept form of the equation. We're going to be using y equals mx plus b again. And I've done a number of videos talking about slope and linear algebra and the slope-intercept form of the equation. I would highly, and other tutors have also done a number of videos like this, highly recommend you watch these, but I put together a couple of note pages. And so this is a note page I had for one of the other videos. Let me fill it all in. I would highly recommend that you take a screenshot of this. And if you don't have the ability to do that, then I would get some paper and I would jot down all of this information. Walking into the test, you need to have this information memorized in your brain. All they're going to tell you is y equals mx plus b. You have to be able to figure out how to calculate your m, or your slope, and how to calculate your b, which is your y-intercept. So, and this note page can help you do that. Hopefully you snapped a picture of it. Y-intercept. This is another note page to help you calculate the b value or the y-intercept. Again, either jot it down or snap a screenshot or get your phone and take a picture of it. Need to have this completely memorized. Okay. So now we're back to our problem. We have to create an equation that models the data for each tree so that you can predict the diameter in the future. So we are completing a linear equation for tree number 1, where x is the year and y is the trunk diameter in inches. Okay, so we know that our linear equation is going to look similar to y equals mx plus b. But in the position where it says m, we have to calculate the slope or the rate for tree 1. So how are we going to do that? Well, we look at our note page first of all, and I went ahead and captured some of the part of that note page. And it said when we need to find the slope or the m value in a table, we need to take the change in y and divide that by the change in x. Here's what that means. Here is our x value is on the left and our y value is on the right. And we need to look at, as we go down from one row to the next, what is happening. And when we look at our y values, we go from 18.6 to 19.2. Our y values are actually increasing by 0.6. And that continues over and over and over. I didn't mark it every time because it was getting very crowded and hard to read. But every line, our y value gets 0.6 bigger. Now we also need to look at what's happening with our x values. Every time we go down, our x value increases by 2. Remember, they said that she was collecting data every other year. So we need to pay attention to that. And so from 3 to 5, yep, 2 again. 5 to 7, yep, 2 again. Okay, so to get the slope, we need to take the change in y, which was 0.6, and divide that by the change in x, which is 2. So that just looks like this. 0.6 divided by 2. This is how the y was changing. Divided it by how the x was changing. We simplify that, and it equals 0.3. So we're going to substitute 0.3 right there in this equation where we have the green m. In a minute, we're going to take the green m away, and we're going to put 0.3 in that spot because that is our slope, or that is our rate, you'll hear it called. But we're not finished yet because we still have to come up with the value that's going to go right here for B. And if you'll remember our y-intercept note page, it said that when you're looking at a table of values, you need to find what the value of y is when x equals 0. And that will be your starting point, or that will be your y-intercept. Okay, now this data is tricky a little bit because they didn't tell us when the value of at year 0, or the value of 0, how big the trunk's diameter was. So it's our job to figure that out. So I tell students, go back, kind of separate out your table like I did. Go back, and you're going to have to ooch in the value of 0. And once you've got the value of 0 in there, you're going to have to figure out what the y value would be. And whatever this number is right here, that's going to be your y-intercept. That's going to be the number that we write in this position of the equation, in the B position. So they did not make this problem easy for us. Okay, every time x is getting 2 bigger, except for when we go from 0 to 1, we didn't get 2 bigger. We only got 1 bigger. Okay, so we're going to have a similar pattern on the right side with our y's. Every time our y values got 0.6 bigger. But we're not talking about the time length of 2 years. We're talking about the time length of 1 year. So we have to figure out, well, if it gets 0.6 bigger in 2 years, in 1 year, it's only going to get 0.3 bigger. And so I like to draw it out here because it makes more sense when we see, okay, well, in the course of 1 year, it got 0.3 bigger, but the rest of the time it keeps getting 2 years bigger. That's why this is 0.6. So our B value is going to be 0.3. I put down an equation that, maybe it makes sense to you. I took 18.6 and I subtracted 0.3, but it's the reasoning, figuring out that 18.3 belongs in this spot. That's what makes it our y-intercept. So we've got all of this information, and we need to use this to fill in our equation. So we know it's supposed to look kind of like y equals mx plus b. So they already wrote the y and the equals. The m, we said, needs to be 0.3. And they've got 0.3 right there. So ideally, you would drag that and put it right up into this position. And then after the m value, we've got x. That's our independent variable. And that's just going to stay x. So we could put in any number of years, like we could learn about 7 years or 12 years or 25 years or 100 years to see what's going to happen to these trees in the future. And they have an X down here, so we need to drag that up there and put it in that position. Now it says plus, and we need to put our y-intercept. And we figured out that our y-intercept would be 18.3. Also an option, we're going to drag that right there. And that is your correct answer, worth 2 points. And we're still not done with this problem. In year 13, the scientists will put tree wrap around tree 1 to protect it from the winter snow. The height of the tree wrap needs to be 45 inches. And then it says the wrap is priced by the square foot. To the nearest square foot, how many square feet of wrap does she need? And then you've got your options. Okay. So basically, what we're doing is, again, we're looking at tree 1. So we're only focusing on the data for tree 1. We're going to put this green piece of mesh. And we need to think about, if I'm buying this, it's not going to be circular, or it's not going to be a cylinder at the store. It's going to be a flat piece of mesh. And so when I cut it open, imagine that you're cutting that open and you're flattening it out. It's going to look like, there you go. It's going to look like a rectangle. So your rectangle, so I cut right there on the green mesh, flattened it out, it's a rectangle. I know my rectangle is 45 inches tall, but what I don't know is this distance across the top of my rectangle. So I go back to my tree picture. This distance across the top is going to be the exact distance to go around the tree. So the circle at the top of my cylinder, the distance around that circle, when I flatten it out, that's going to be the length across the top of this rectangle. So hopefully you know that there is a formula to help us find the distance around a circle, and that's called the circumference. So we're back to our GED formula page. There's a couple of formulas we're going to need. One of them is to find the area of the rectangle. Area equals length times width. But also, we're going to use this one towards the bottom to help us find the circumference of a circle, or the distance around. There are actually two accepted formulas to find the circumference of a circle. One of them is circumference equals 2 pi r, or you could use circumference equals pi d. Whenever you're working with pi on this GED practice test, they're telling you they want you to use 3.14 as an equivalent, and don't use the actual pi key on your calculator. So let's see here. So now we know we need to find the distance around this circle. We had two formulas for circumference, but we are going to use circumference equals pi d. And the reason we're going to use this formula is because in our chart of values here, our information is given as a diameter. So they're giving us diameter, so we want to use that formula. If they had given us the radius, we would have used the other formula. So now we're just substituting. And remember, we're looking at tree 1. And tree 1 had a trunk diameter of 22.2 inches. So they told us that we're going to substitute the value of 3.14 for pi, and the diameter in year 13 is 22.2. So I'm going to write out my equation just like this. I've done my substitution. So now let's put it into our calculator. Clear all that out. Okay, so now I'm going to put in 3.14, open parentheses, 22.2, close parentheses. I like that they've got the view in here because you can make sure that you typed it in correctly before you continue. And so I'm going to press enter, and that equals 69.708, which is the correct answer. But we're not done yet. Remember, 69.708, we were calculating this distance right here at the top of the rectangle. The circumference, the distance around the circle at the top of the cylinder, when it was flattened out, it's that straight line, and we now know it's 69.708. But to find the area of this rectangle, because we have to know the area in order to purchase it, we're going to have to use our formula, area equals length times width, 45 times by 69.708. I already have 69.708 in my calculator. I'm just going to click multiply by 45, and that is going to equal 3,136.86. And I'm going to tell you that's a correct answer. Hopefully that looks familiar to you. But unfortunately, let's look at our answer choices. It says the wrap is priced by the square foot. So then here in square foot, how many square feet of wrap does she need? And 3,136.86 inches squared is not an option, not even close to an option. But if you read closely, they're telling us they want our answer stated in square feet. And we've only been working in inches, so our answer was in square inches. Now we have to think about what changes. How are we going to convert square inches into square feet? So I drew 1 square foot. And 1 square foot is going to be 12 inches tall and 12 inches wide. And if I were to make the grid and draw the line, we would have 144 tiny little square inches inside this box. So for every 144 square inches, we're going to have 1 square foot. That means that we need to take our answer, 3,136.86, and divide that by 144. So our calculator still has our answer on it. I'm just going to click divided by 144. Press enter. That now equals 21.78375. And let's go back and compare to our answer choices now. It says to the nearest square foot. So hint, hint, we're going to have to do some rounding. How many square feet of wrap does she need? Well, 21.78375 is very close to 22, answer option A, so that's the one we would select. Now finally, 4 points later, we are finished with our tree problem. And we're looking at practice question number 8. The graph shows the level of ibuprofen, Y units, in a patient's bloodstream, X hours after the ibuprofen was taken. The level of ibuprofen in the patient's bloodstream increased from blank hours to blank hours. And when you're on this page, if you click the first box that says select, you're going to get these answer choices. And if you click the second box that says select, you're going to get these answer choices. Okay, so at this point, go ahead and pause the video, solve this problem, and then we'll go over it in just a sec. Okay, the video is turned back on now. So it says, the question that we're answering says, the level of ibuprofen in the patient's bloodstream increased from what hour to what hour? So we have to look at the chart and we need to find the place where the ibuprofen level is going up or increasing. And on this graph, we only have one spot where it's actually going up. That kind of makes sense. You take medicine, it goes into effect, and then it slowly starts to wear off. But the only place where we see increase is right here at the beginning of our graph. So the increase started at right there at 0. So we're looking at time, how many hours? So right there at 0 hours is when it started, and that is an option. And it goes up, 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 up. It hits its peak. We haven't even made it to 1 hour. It is less than 1 hour when it stopped increasing. Fortunately, we look over at our answer choices, we have an option of 2/3 of an hour. So it increased from 0 hours to 2/3 hours. Okay, this problem is a geometry problem. An office uses paper drinking cups in the shape of a cone with dimensions as shown. So the height of the cone is 4 inches and the diameter, or the distance across, is 2 3/4 inches. Then it says, to the nearest tenth of a cubic inch, what is the volume of each drinking cup? Again, we do have our formula page, and they do have the volume formula for a cone right here. V equals 1/3 pi r squared h. So let's start substituting. So I've circled our equation, and I rewrote it just because I always do that. So that's our equation. And so 1/3 is 1/3. Pi, they've told us that on the practice test, and I believe on the GED, we're always going to substitute 3.14 instead of using a different, more precise value of pi. And so we're going to put 3.14 in this spot. R stands for radius, so we're going to put our radius, which we don't know. And we're going to square that value, and then we're going to substitute our height. And they did tell us our height is 4 inches. So the first thing we have to do is figure out what a radius is and then figure out the radius for this problem. I also did a video a while back on geometry and on finding area and perimeters and circumference. So here is a little note page on the circle. The diameter is in red. It's the distance across the circle traveling through the center. The radius is in green. That is the distance from the center to any point on the edge. The radius will always be 1/2 the distance of the diameter. So it gave us the diameter. We need to figure the radius. And so let's use our handy dandy calculator to help us do that. So I'm going to clear out our last problem. I thought this might be a good opportunity to show how to use the mixed number fraction that they actually have as a second function. On the practice test, that calculator, you have to look because sometimes they move those second functions to different keys. So be careful that you're looking in the right spot. On this calculator that I'm using, it's right above the number 7. So the 7 key in gray, right above that, we've got a box that looks like where the whole number would be, and then a box over a box, which is where our fraction would be. I want to use that function. So I'm going to click second, and then I'm going to click 7 key, and I've got this. So I want to put in 2, because that's my whole number. And now if I were to put in 3 right now, the calculator thinks I want 23. I don't want 23. I want to go up here to the top part of my fraction. So I am going to not go up. Stop messing up. Okay, I've got my 2. I'm going to go forward. There we go. Now I've got my blinking cursor at the top part of my fraction. So trying to put in 2 3/4. So I've got my 3. Now I need to put in my denominator for my fraction. So I need to arrow down to get my blinking cursor to go down. Blinking cursor's in the correct place. I'm going to hit 4. And now I don't want it to think I'm working with, 3/45 or some big number. So I have to arrow forward to say we're finished writing our fraction. There we go. Now my cursor is where I want it. I'm going to say divided by 2 equals 11/8. What if I didn't want to use a fraction like 11/8? I'm going to use my toggle key down here in the bottom right corner to turn that into a decimal. I sometimes find that decimals are easier for me to work with. So instead of 11/8, I'm going to use 1.375. Okay, so now let's start substituting here. So I'm going to have 1/3. I'm substituting 3.14 for pi. I'm substituting the length of my radius, which is 1.375 for my radius. And then I'm putting parentheses around it, and I am squaring that amount. And then I'm going to put parentheses and include my height, which they told me was 4. Okay, so now get my calculator going again. I'm going to clear some of this. Too much going on here. So I'm going to use my fraction button, which is right here. And I'm going to put in 1. And I'm going to arrow down to get my 1/3. I'm finished writing 1/3, so I'm going to arrow to the right. I'm going to put my parentheses. I need to put in 3.14 for pi, close parentheses. I'm going to open parentheses again, 1.375, close parentheses. I'm going to square that. So I'm actually going to use the X squared button right there. Open parentheses, 4, close parentheses. Okay. So now, again, you could look at your screen and make sure you typed it in correctly. You can arrow all the way back to make sure, yep, I got my 1/3 in there correctly. Yep, I've got everything else looks good. Okay, so now I'm going to press Enter. My answer is 7.915416667. Okay. And that is correct. Let me see if it's come in. Oh, I'm just showing here. This is the calculator that I think you'll be given on screen for the GED. So the fraction button is right there. The x squared button is right there. Slightly different than the one I'm using today. I rounded my answer. I didn't put down the whole thing. 7.92 inches cubed. And so now we have to look at our answer choices. And they tell us to the nearest tenth of a cubic inch. So they want us to round it even more. What is the volume of each drinking cup? So instead of 7.92, they've listed it as 7.9. So option B is the correct answer. We have one more question, and I think we should have time for it. There are S steps from the pedestal to the head of the Statue of Liberty. The number of steps in the Washington Monument is 27 less than 6 times the number of steps in the Statue of Liberty. Which expression represents the number of steps in the Washington Monument in terms of S? So again, the number of videos talking about how to turn words into a math equation. But the first thing I like to do is write down my knowns. Somewhere, I like to write down my knowns. There we go. The Statue of Liberty, they told us, has S steps. For the Washington Monument, they said, let me see, that the number of steps is 27 less. So when they're saying it's going to be 27 less, it's like we know we're going to have to subtract 27. Then it says 27 less than 6 times the number of steps in the Statue of Liberty. So 6 times S would just be written as 6S. So the correct answer would be 6S minus 27. That happens to be option C. We'll take it. That was a pretty good representation, I thought, for GED math questions. Hopefully you did pretty well, or at least you followed along okay with me. Highly recommend that you give it 3, 4, 5 days. Go back, click on to the original site to take this test yourself online. See how you do. See if you remember some of this information. But in the meantime, you have a great week.